Okay, so let's take a look at question 1. This is our Unit 6 end of unit assessment review. The function f of x equals x squared plus 4x is graphed on the coordinate plane. Which statement is true about the graph of f? The graph has a y-intercept at 4 comma 0. Well, if I take a look at this, and I know it's ax plus bx plus c, right? I can assume that my c is 0. Okay, also I noticed that this, right, so my y-intercept should be at 0, and they try to trick you by having that 0 here, but also your x should be 0, so in the case of this function, your y-intercept should be at the origin. Okay, so because whenever it crosses the y-axis, your x value is going to be 0, so it can't be this one. Okay, I'm going to skip B because I have to do a little work to figure that out. Right? Because it's talking about the vertex. So now I'm going to go to the graph of the function opens downwards. Well, this is a positive function, so it's actually going to open upwards. And this is just an image. This is not what the graph really looks like. It looks like this shape, but it's not the exact kind of coordinates. All right, so now we have the x-intercepts are at negative 4 comma 0 and 0 comma 0. Well, we already saw that there is an intercept here because the intercept for y is at 0, and we also know that the x value should be 0. So this is an x-intercept. So that's easy to see. And then if I was to plug in negative 4 in this equation, right, and so then I would have negative 4 squared. I'm just actually going to put that square on the outside of it, plus 4 times negative 4, I would end up with 16 minus 16, which is 0. So that is our x-intercepts. Okay, so that is true. So now I know it can't be B anyway. But let's just go through B and D with the calculator just in case the algebra, is kind of difficult to understand, which I get. It's a lot of thinking about the graphs of quadratics. So let's go to y equals. I already have this in here, and I'll show you what the graph looks like, okay? So you can see that it crosses the y-axis over here. But let's just do the calculation of the minimum, which is our vertex. And we have it at enter. That was our left bound. This is our right bound. Okay, and then we're going to hit enter to calculate. And so our minimum value, our vertex is at negative 2 comma negative 4. So that's not true because it shows positive 2, right? Negative 4. So that's not true. I'm just putting these back out here. So another thing we can do is check the table for our x-intercepts, and we go to negative 4, okay, at negative 4, y is 0, and at 0, y is 0. So it confirms, our algebra is confirmed on the table. Now, you could go straight to the table. This is something where you could be like, okay, let me see if negative 4 comma 0 is an intercept, right? That's an easy way to do it as well, rather than doing the algebra, and that's fine. So here's a graph of a quadratic function f. Okay, here is a graph of quadratic function f. Select all equations that could define the function f. Okay, so there's a couple of things. I don't know why it made this line here. That doesn't mean to cross out. I'm going to do, and I am going to put in to see, okay, well, automatically I see I have these as my intercepts, right? So x equals, wow, I can't see this good. But to me, okay, x equals 1, I could see it here. X equals 1, and then x also equals 5, okay? So I know that I have to have something that looks like, right, x minus 1 x minus 5. Okay, this equation should be what I'm looking for. And I'm going to double check it here. All right. X minus 1. I'm just going to check to make sure that it fits my vertex. And we have x minus 5. Okay, and then I'm going to calculate my minimum. Yes, it's a minimum. Okay, and I go to my left bound. I'm going to my right bound. Enter. Okay, so it's at about 3 comma negative 4-ish, and that's what I have here, 3 comma negative 4. So I know that I'm looking for something that looks like this, which is B. So let's see if anything else is equivalent to this graph and this equation. Wow. How can I do that? I can see, right, which ones, and I could have done, if I don't know how to do the math and how to see how my intercepts help me with writing a quadratic in factored form, then the graphing on the calculator will be so helpful. So I am going to leave that there, and I'll try the first one. X minus 10 times x minus 6. Okay, and I'll just hit graph to see. Okay, they're not equal. That's clear. So I'll do the next one. Clear that up, and I'll do x minus 3. All right. And this is squared minus 4. Okay, and I'm going to graph it. And that graph is equivalent. And I could have kind of told that because, okay, I know the minus 4 is there. Okay, and I also know that this graph, because I know, like, it moved over 3 spots, right? It moved to the right 3 spots. And if you're not sure, again, you can use your graph and see that it's equivalent. And you could also use the table, and you see that your y values are equal for the same x values. Okay, so let's try another one. And I'm just going to go down here. And, okay, I'm pretty sure that this one is not equivalent because, right, there should be a 3 in here. But I just want you to see and graph, and we see that they are not equivalent. And then my last one, I'm going to get rid of this. And remember, I had 2 graphs here. Yep, it goes so fast, it's hard to see. And I'm going to do x squared minus 6x plus 5. And I'm going to hit graph. And I see there's only one graph. And if I go to the table, I notice all of my y values are equal. So we have B, we have C, and we have E. And they are all equal. It looks like E and F are the same thing. Something must have went off there. There must have been a minus that was off. So when I put it up later, I might change this out or just cross it out on your paper. Or someone will notice that they're 2 of the same. Okay, but there are 3 answers to this equation. Okay, a quadratic function is given by f of x equals ax squared plus bx plus c. Select all statements that must be true. The y-intercept is at 0, comma c. That's true, okay? The y-intercept, no matter where it is, our x is 0, and then our c is telling us what the y value is. If a is less than 0, right, the graph opens downwards. Not really that it has to be under that line there. It just opens like a frown face instead of a smiley face, or a mountain instead of a valley. So, okay, this is also true. If b equals 0, the vertex is on the x-axis. That seems like that is not true. the graph, so this is not true. The graph always has two x-intercepts. That's also not true. Sometimes it could have only one x-intercept. Sometimes it has no x-intercepts. Okay, it could actually be off the axis. It could be like that. Okay, it could just not be crossing the axis at all. Okay, so when a is greater than 1, the graph of x is more narrow and a skinnier parabola. That is true. So we have 1, we have 2, and we have 3 as true. Okay, 4. I changed my grid because I needed more. And I also added these coordinate planes, which is, you want to do that while you'll just have a plain grid there. Let me see if I could get rid of them for, okay. So I'm going to make a coordinate plane. I like using red just because, but I don't always do that. And I put it up top here because I've actually graphed it before, so I know that it is going to need a lot of negative space. However, if you don't know that, that's okay. You will figure that out as you're graphing and as you're concluding stuff. So the first thing I want to do is have my x-intercepts and label them. So I see here that I'm going to have an intercept at positive 2. Get black now. And I'm going to have an intercept at negative 6, right? Negative 6 plus 6 equals 0. Okay, now if you're wondering how I figured that out, okay, I set each factor of my equation, sorry, I want to make that a 2, equal to 0. Right, x equals 2. Remember, when you're at the x-intercept, y is equal to 0. So x plus 6 equals 0. Okay, and so x equals negative 6. Okay, that is how you find your x-intercept. How do you find your y-intercept? Well, for your y-intercept, your x's are 0. Okay, so you can actually just, let me see, so we could make x 0, we're just going to plug it in so that we have minus 2, right? 0 minus 2 is minus 2, okay, and x is 0 plus 6, so that's 6. All right, so it's at negative 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, so that's my y-intercept, and now I need to find my vertex. How do I find my vertex? There's a couple of different ways, and so if you don't remember how to do the y-intercept like that, where you're setting your x's to 0, you can also do the box, right? You could also do that area model, and then when you get up to your c, right, your c is going to be negative 12. Okay. So, and then over here I figured out actually where the vertex would be by going to count the amount of spaces, right, in between these two. Oh, that was awful. Okay, the amount of space in between. Okay, not making a graph, I just wanted to point that out. So the amount of space between from negative 6 to positive 2 is 8. Then I divided it by 2. So I know that the vertex is going to be 4 points away from this x-intercept and 4 points away from this x-intercept. 1, 2, 3, 4, because remember it's in the middle of those 2 points, okay? So I know that there is going to be, right, a axis of symmetry down this. Ugh, I don't like the way that came out, but, ooh. It's really hard to make that straight. Anyway, there's an axis of symmetry down x equals -2. Okay, so now to find the vertex, I'm going to plug in -2 to my equation. Let me see if I can move this around so you can see it. Okay, the math work is right here. If I have to, I'll rewrite the math work, but it seems nonsensical. So -2 minus 2, -2 plus 6, and we end up with -4 times 4, which is -16. So we are going to go to -16. This is 12, 13, 14, 15, 16. Okay, you do not have to put that axis of symmetry there. I just put it there to make it easier for me. I'm actually thinking that I want to take it away now just to be able to see things better. Okay. Alright, so, and I don't need this anymore. Okay. And now you want to draw your parabola. So, you know that you are going to have a line that's going through. Oh, I used the dotted one on accident, but it came out actually better than when I used the non-dotted one, but I'm going to use the solid line. It is really hard to draw a parabola with this. Okay, I'm going to put that arrow there. And then I actually want to put a few, nah, I'm not going to. I should have left the axis of symmetry so I can draw it easier to see where my points would go. So it would be easier to draw, because I would like this to be a little less narrow than it is. Okay, it's pretty much good enough, right? As long as you have your points correct and then you have an x-intercept here. And that is at -6, comma 0. And then you have an x-intercept here. And this is 2, comma 0. See how I'm labeling the points, right? And I do that by just, maybe I'll take an arrow to the point. I would usually put this math closer to where the dot is. It's just hard to draw with this. So we found that the y-intercept was at 0, comma -12. Okay, and that's the y-intercept. And then we have our vertex. Trust me, it is not easy to write this all with a mouse. This actually is an R. Okay, and it's at and it is at, we found it was -2, right? Because that's where our axis of symmetry is, -16. Okay, and it's a minimum. Now, if you don't know how to do all that math, it is okay, because your calculator will do math for you. Okay, we'll do the calculations for you. I shouldn't say math, but calculations. So let's bring it up and go to y equals, and we're going to put in the original equation, x minus 2 times x plus 6. Sorry, excuse me. And we could hit graph to take a look at it. Oh, graph. Okay, and oh, I don't know how to find my intercepts. You could hit second calculate. Okay, and you go to zeros, right? Because your intercepts are also called zeros. And we'll do the left one. Go to the left bound. I'm going to go past the x-axis, and then I'll go to the right bound, right? I'm not going all the way to the right of the graph. I'm just going to the right of that x-intercept, right? Hit enter, and then hit enter, and it gives me, hit enter, go back. What did I do wrong? Graph, calculate, 0. So we have our left bound, our right bound. Oh, I might not have did the bounds correctly, and now I'm going to guess. All right, and it tells me at -6, 0, right? I have a intercept here. So that would be my first one. Now I want to find the one to the right, right? Because there's 2 intercepts in this one. So I'm going to go back to second. Then I'm going to hit trace for calculate, and I'm going to go to 0. And now I'm going to find, this says left bound, so I want to stay on the left side of the intercept. And then when I find my right bound, I'm going on the right side of the intercept, and then I'm going to hit guess, and it says at 2, 0. So now that's how I found both of my intercepts using the calculator. Okay, I can also find my minimum or maximum value. In this case, it's a minimum, right? By going to second, calculate, and so second, calculate, minimum. Then I'm going to go do my left bound. And remember, now I'm going to go to the left of the vertex, right? Because I'm not looking for x-intercepts, I'm looking for the vertex points. Okay, hit guess, and this tells me at -2, and when y is 16. So when x is -2 and y is -16, I have the vertex, or you have the vertex. Okay, now for y-intercepts, I don't see the calculate there. So what you can do though is, you know, for your y-intercept x is 0, you can go to where x is 0 and you see it's at -12. Okay, another way you could have done that is just doing the area model or box model, right? And then when you find c, right, your c is -12. Okay, look at question 5. All right, we have, here is a graph that represents the height of a baseball H in feet as a function of time t in seconds after it was hit by player A. Okay, so they give you the graph here for player A. The function g defined by g of t is -16t minus 1 times 1 minus 4. I'm sorry, times t minus 4. Okay, -16t minus 1 times t minus 4. Also represents the height in feet of a baseball t seconds after it was hit by player B, without graphing function g. After the following questions, answer the following questions and explain or show how you know. Okay, so let's take a look at baseball player B's equation here. So, and let's take a look at baseball player A's time. So baseball player A's time is, it hits the ground in 5 seconds. That's my dog. She barks because there's an alarm going off. Roxy! Come here, baby. It's not going to stop. She's a barker. She's a barker. Okay, so 5 seconds. So now I'm going to find baseball player B. So how do I find baseball player B's time? Well, if that's, sorry, this is not actually 5 seconds, a little more than 5 seconds. Okay, so now baseball player B's time. So I'm going to set each of my factors to 0 to see where my x-intercepts are, right? And so this is a -1. This is actually a t, just in case you don't see that. And this is -1. So we end up with 16t. Well, it's negative 16t equals 1, right? Because I add 1 to both sides. Okay, and then I want to divide out the -16 on both sides. So this gets crossed out. And t equals 1 over -16. So it would be the time here, right, for this intercept would be negative. So for this function, one of the intercepts are on the negative x values. We can't use this factor for the time. We can use it to find out to find a vertex, right? We're going to need it because that's the function. That's what it's defined as, right? But this intercept doesn't make sense as far as when the time started. Time started at 0 for both, okay? Even if it didn't start at, right, the ground, the time started at 0. Okay, so let's do the other one. And the other one we have t minus 4 equals 0. And we have t equals 4. Okay, so our x-intercepts are at this negative, and then t equals 4. So baseball player B's ball lands at 4 seconds. A's ball is a little bit more than 5 seconds. So baseball player A's ball, right, is actually stayed in flight about a minute longer than baseball player B. Okay, or you could just say baseball players A's ball stayed in longer. It's up to you, as long as it makes sense for the context of the question. So which player's ball reached a greater maximum height? This is above 100. Maybe it's 110. I'm just taking wild guesses here. So to find the maximum height, I already have it in here. I actually put it in the calculator. There are other ways you can do this, but for me personally, I find it easier to use the calculator. And it said to do it without graphing, but on your Regents, you have a calculator. You're allowed to use a calculator to solve your problems. Okay, so I have the equation in, okay, and just so you see the graph, okay, so I'm gonna hit calculate, and because this graph makes like a mountain or a frown face, right, I'm gonna hit maximum, not minimum. And then it asks me for the left bound, so I go to the left side of the vertex and I go to the right side of the vertex, and then I let it guess, and it shows me that the maximum value is when x is about 1.92 seconds, right? And y is at 66. So 66 is less than over 100. So player A reached the greater maximum height. So player A reached a greater maximum height. Okay. How can you find the height at which the baseball was hit? How can you find the height at which the baseball was hit? While the baseball was hit, right, at the starting point 0 seconds. So that would be the y-intercept. When x is 0, we find out where the function crosses y. So I'm going to say set x equal to 0, 0, and solve, for example, right? Well, in this case, I'm going to say t, not x. T equal to 0 and solve at this point. I'm going to make negative 16, right, times 0, right? And that was minus 1, okay? And then I have 0 minus 4, okay? So I end up with, okay, negative 16 times 0 is 0, minus 1 is negative 1. So I have negative 1, right, times negative 4, okay? And that gives me equals 4. So player B's ball started at a height of 4 feet, okay? And that's how you would find it, right? That's how you find the y-intercept. Set t equal to 0. I'm actually going to change this to set t equal to 0 to find the y-intercept. Okay, I think that makes better sense or more sense, and this shows you how to do it. Okay. So let's take a look at number 6. Adrian and Sam stand on a short bridge spanning a creek. They each have a stick to throw and plan to throw them at the same time. The function p of x equals negative 10t minus 5, and t minus 1.5 represents the height of the stick t seconds after it was thrown by Adrian. The graph represents the height of the stick t seconds after it was thrown off the bridge by Sam. Whose stick took longer to hit the water? How long? Okay, so this is Sam's stick, and I want to point out again, that, right, this stick is being thrown from the bridge from here. Okay, this is the function's graph, but it starts at 0 time. Okay, and it goes a distance, right, from 0 to 1 seconds. So it takes 1 second for Sam's ball to hit the ground. Now, we have the same issue that we had with the last question, right? We're going to set our factors equal to 0, and we end up with 5 over, well, it's going to be negative 10, so just negative 5 over 10 equals t. Okay, so one of our times is on the negative side, right? So we're not going to use that as part of our situation to find out how long it took, right? But we do have t equals 1.5, right? Can be used. And all I did there was set this factor, t minus 1.5 equal to 0, and then solve for t. So this is bothering me. I'm going to just erase it. It would make my life easier. Okay, so the Sam's took 1 second and Adrian's took 1.5 seconds. So whose took longer to hit the water? Adrian stick took longer to hit the water by half a second. It took 1.5 seconds. Something like that. Sam's stick reached a maximum height at about 1/4 second after it was thrown. Did Adrian's reach a maximum height? Sorry, did Adrian's reach a higher maximum height? So I'm going to go into here. I'm going to plug in this equation, which was negative 10 minus, negative 10. I'm going to put x in here, minus 5 times x minus 1.5. Okay, now I'm going to graph it just to see. Okay, now I'm going to find my max value. So my maximum height, right, my left bound, and then I do my right bound, my right side of the vertex, and then I hit guess. Okay, and the maximum height was when y is 10, and it was at 0.5 seconds. So it was 1/2 a second. So did Adrian's reach a higher maximum height than Sam? Looking at this. Okay. 5, 6, 7, 8, 9. So Sam's is 9 and Adrian's is 10. So yes, Adrian's. How did I find this? I counted it. Each grid is one space, right? From 0 to 5 was 5 spaces. So 1, 2, 3, 4, 5, 6, 7, 8, 9, right? Your max is right here. So Adrian's is higher. Higher. Right? Reached a higher max height. Okay. What was the maximum height of Adrian's? This says stone. I think we used sticks. I'm going to say stick. Gotta fix these on here. Adrian's stick. And it went to a maximum height. Was 10 feet. Okay. A quadratic function is defined by, and this is the equation they give, h of x equals x minus 2 squared minus 5. What is the vertex of the graph of h? Okay, so we didn't go over vertex form that much. This is in vertex form, so you might want to use the calculator for this. Y equals, we have x, is this minus 2? Yep, minus 2, okay, minus 5. And we're going to, whoop, I did something wrong, right? It needs the square. Okay, minus 5. Okay, I saw that it wasn't the right shape. I knew something was wrong. Okay, so this is my graph. Now, my vertex is my minimum. I see that it's making a minimum. So I'm going to hit minimum. I'm going to go to my left bound. I'm going to go to my right bound. And the minimum is at -5 when y equals -5 and x is at about 2. So the vertex is at 2, comma, right, -5. Okay, now if you notice, this is called vertex form because you have your -5 and your x, right, is 2. 2 minus 2 is 0. Okay, so if you think about it, it's actually that this original function is x squared. This is the function x squared. X minus 2 means that this function moved over to the right because x is 2, right? We're looking at x being 2. Minus 2 equals 0, right? So x equals 2. Okay, so 1, 2, and then it's down 5. Okay, let's just pretend because I don't feel like writing out numbers. So that graph moved over 2 spaces and down 5. All right, 2 spaces to the right. What does the vertex, does the vertex represent the minimum or maximum? Ooh, did I do this? I know it actually found it correct. It's minimum. I'm like, I hope I chose minimum. If I didn't, the calculator did it correctly regardless. But I would put in the correct one. So, minimum. Right, because the graph formed is positive. or the function is positive. Or, right, your A is greater than that. I think actually that would be the best one. Because A is greater than 0. Okay, like ax squared plus bx plus c, right? Your A is greater than 0, therefore the vertex, therefore it forms a graph that looks like this, right? Kind of. Let's pretend that I can draw, right? It makes kind of a smiley face. Oh God, it doesn't get better. I just can't draw. Okay, so that's a minimum value. If you were to shift the graph 4 units up from where it is now, what would be the equation represented by the new graph? So 4 units up, right? You would keep your x minus 2 squared. So you have 5 here, negative 5, right? 4 units up is plus 4, because remember, right, this is up and down. So our answer would be x minus 2 squared. Just write it. It's easier for me. Sorry. Okay. X minus 2 squared, right? Negative 5 plus 4, right? So we have negative 5 plus 4 is minus 1. Okay. Oof. This looks gross. Let me make this look better. Okay, that looks a little better. All right, so that would be what the equation for the new graph would be. Okay. It doesn't say move left or right, so I left this inside here the same. Okay. The function h defined by h of t equals 36 plus 6t times 5 minus t models the height in meters of an object t seconds after it is dropped from a drone. Find or approximate the time when the object hits the ground. Explain or show your reasoning. So over here, right, we're going to, again, set 36 minus 6t to 0, right? And in that case, we find t equals, right? T equals negative 6, right? Because 6 times 6 is 36. Actually, it equals 6. Sorry, t equals 6, right? Because we have the 6 is negative, right? So negative 6 times 6 is negative 36. So 36 minus 36 is 0. Okay, and in this case, our t is 5. You can see that easily. 5 minus t equals 0, right? T equals... Actually, you cannot see that easily. I even made a mistake there. T does not equal 5 in this case. Okay, so let's see why not. As I was writing it, I was like, where did that negative go? All right, so let's just solve this. So 5 actually equals, T does equal 5. 5 equals T. I'm thinking of a different example where I had to move things around. So yeah, so we brought T to the other side, or we added T to both sides, and we got 5 equals T. So these are our values for T, right? Our solution, T equals 6, T equals 5. So find the approximate time when the object hits the ground. Explain or show your reasoning. something is up here. Ah, I wrote this wrong. Duh. Okay, that makes sense. All right, so this should be -6. Sorry, that was a plus sign. Some of you might have caught it right away and just saw, wow, what are you doing there? That should be a plus sign, right? That changes everything, because I was looking at this going, why are both the intercepts in the positive if it's being dropped by a drone, right? So we should have a graph, right? Let me see if I can... We're going to have a graph, and the negative sides are not going to count, right? So it's going to be thrown by something and land. I'm going to kind of say it's like this. So one of them had to be negative in my eyes. So I knew something was wrong. So now we have -6, t equals -6, and t equals 5. Okay, so the approximate amount of seconds it took the object to hit the ground was 5 seconds, okay? Because only one of the t's really matter in this situation, right? So it took 5 seconds. Okay, from what height was the object dropped? Explain or show your reasoning. Well, if we know that our y-intercept happens when t is 0, right, we're going to set t equal to 0. So 36 plus 6 times 0. This is the worst. Let me just do this one. 36 plus 6 times 0 times 5 minus 0. Okay, we end up with 36, right? Because 36 times 36 plus 6 times 0 is 36, and 5 minus 0 is 5. Okay, so we end up with a height that was 36 times 5. So I'm going to pull this up, and 36 times 5. So it was dropped at a height of about 180 meters, right? So it was dropped at a height 180 meters. Now, you could put this in here. 36 plus 6x times 5 minus x. Okay, go to your graph. You want to hit about here, or you want to be where x equals 0, right? You can trace it if you're not sure how to get there, and you see that when x equals 0, y is 180. Okay, you can go to the table and find when x equals 0, y is 180. But I don't see the, I don't see a y-intercept calculate there. Okay, so it was dropped from a height of 180 meters. All right, let's take a look at question 9. These examples are similar to Regents questions now. So we have 3 quadratic functions, right? F of x equals x plus 1 squared plus 4. This is actually not part of it. I put it here to be able to do graphing. I'll put it back in a second. Then we have this table, and then we have another graph, and it says which of these functions have the same vertex. Okay, so for this function, I can tell, and if you can't, that's okay, you can graph it. The vertex is at -1, comma 4. I can tell from looking at this that my x is -1, and that So my graph, my original parent function was where my vertex was at 0, 0. Okay. This is the parent function x squared. We're going to pretend that looks right. Right? That's x squared. And it moved 1 unit to the left. So let's say this is -1. And it moved 4 units up. 1, 2, 3, 4. I'm just making pretend spots. So the new one is at, right, -1, -4. Okay, it moved it over. It's like playing chess a little bit. All right, just slid over and moved up. Okay, and if you're not sure about that, use your calculator. That's what's beautiful about it, right? So we have x, right, plus 1 squared plus 4. Hit graph. Okay, calculate. You don't have to hit graph. You could actually go straight to calculate. I just like seeing the graph to make sure it looks right, like I put everything right. Do my bounds. Okay, so it looks like at negative 0.999, which is about -1. Okay, and where y is 4. Well, that's actually what I said, -1, 4. Okay, either way you get there works. Now let's take a look at the next one. So I'm going to put this graph back here so you can see. You have a piece of graph paper in the back of your regions, okay? So I'm going to say to you that you might want to use that graph paper as much as you want. You could even draw a graph by just drawing it if you want on your paper. You're allowed to write on your regions. Okay, and I just want to be able to see this, so I'm making it orange. And then I'm going to do... I'm working with Microsoft Word, so it's a little... I keep switching programs because I prefer Microsoft Word, but I wanted to try something new. Okay, so I'm going to put this here, and I want to make it the same color. Okay, so I have my X and Y axis. It's not perfect, but it will do. Well, it's close enough. Put this here, and I'm going to put this a little more over. Okay, so I am going to draw this graph to check it out. Could you use, right, it tells you it's quadratic already. You could just use quadratic regression and then plug in the equation. But I just find this to be good enough. 1, 2, 3, right, and then up 1. Okay, and then I'm going -2, right, up 3. 1, 2, 3. It should be here. Okay. Okay. And then we have at -1. Right, at -1. Let me just actually put this a little more. Wow, that's the worst dot. I can't draw very well, but we all know that. Okay, and then we have at -1, it's at 4. And then we have at 0, it's at 3. And at 1, it's at 1. And at 2, it's at -3. Okay, so you see this parabola here. This is your vertex. So your vertex is at -2. -2. Right. Oh, no, -1. Sorry, -1. comma 4. Let me fix this. It's not -2. It's -1. Okay, that's your vertex. All right. So, which of these functions have the same vertex? So that looks like it's the same. Something is up with this function here. Let me just double check. -2 is at 3. -1 is at 4. 0 is 3. 1 is at 1. And 2 is at -3. Okay, so these have equal vertexes. Let's take a look at the next one. And the next one also is at -1. I'm just double checking. Okay, -1 comma 4 again. So just wanted to see something. So it looks like they all have the same vertex. Again, I'm just double checking everything. But that's what it looks right to me. Yep. So it's 1, 2, and 3. 10. Describe the transformations performed on the graph of f of x equals x squared to obtain the graph of, this is bothering me so much, g of x when g of x equals x minus 2 squared minus 8. I have the answer here. Okay, so let's pretend the answer wasn't there. All right, I'm going to put in these two graphs. F of x is x squared and g of x is x minus 2 squared minus 8. I'm going to graph it. The blue graph is the original, and our vertex is at the origin, 0, 0. And the new graph has moved, looks like, to the right and down. How many units to the right? Well, what's our new vertex at, right? Our new vertex moved 2 units, right, to the right and 8 units down. You can just count them if you want. That works fine. You could also know that if you take a look at this, right, your new vertex tells you where when x is 2, this is 0. So your new vertex is 2 comma -8. So it went from 0, 0 to 2 comma -8, right? So the graph of f of x moved 2 units to the right and 8 units down to get g of x. Okay, so it went from 0, 0 to 2 comma -8. Okay, or the vertex. Let me write that in there. The vertex. Zero, 0 to 2 comma -8. The whole graph moves along with it symmetrically and proportionally, right? Okay, that is it. Good luck on your exam.